discuss. So spacing part,
Hello.
if there is any doubt, you tell me. Someone has asked regarding diameter and all, that you will decide in the beginning before going to the spacing part. Okay, then this is the minimum spacing. And another one thing I forgot to tell you, I told the H section also. Now you see the spacing is 3D. You may not get in the book. This part is given that when you go for board file, when you do for boring, at that time some sort of vibration will be there. So if you look into a pile, green concrete, and immediately if you do the neighboring pile and the vibration takes place, then it will have impact on the strength of the lean concrete. Okay. So the distance is 3D. So if the distance is more, then in that case the propagation of vibration will be less because damping will take place. So that is also one reason to keep the spacing say 3D. And sometimes in some of the projects, we look into effect for this vibration effect of this on green concrete. So that is also one project I have handled. And while doing so, while going through, I found that yes, this spacing also is to be there so that while going for the successive pile construction, the vibration on the green concrete will be less. Okay, so this is one construction aspect. Now let us go to the failure mechanism of a pile group. Now if it is in clay, you can see that it will fail as individually or it will fail as a block. Okay, so if you look into it, the friction that will be acting, if you look into it, if you look into it as a group failure, then the whole thing is settling down. So the as a block failure will take place and friction will develop along the perimeter as well as at the base resistance will develop. Okay, so you have to get the perimeter multiplied by corresponding Li and Ci will give you this component, and the bottom part CNC into Ag, that the gross area multiplied by CNC will give you the capacity. If you are any doubt, you tell me. This is the section and this is the plan. So this is a block failure, and individual failure means it will be N into QU, single pile capacity multiplied by N. So here CNCAG component is coming from this area. This area is this part, and this part is coming from this friction. Because if it is layer wise, say suppose this is L1 has got cohesion say C1, and suppose this is L2 and cohesion C2. So in that case, corresponding length has to be multiplied by this, and this is the perimeter. Whatever perimeter you have got, this is the perimeter you have got. So this is the perimeter actually. Because if you know the spacing, then plus this d by 2, and here again this side d by 2 will be taking s. So it is twice s plus 2 into d by 2 and this multiplied by 4 will give you the perimeter, and you are multiplying with corresponding L and Ci will give you the resistance. Okay, do you have any doubt? Do you have any doubt?
Sir, what is AG?
AG is this area I have marked. If you know the sides, a square, this is the AG, gross area. That's why I have marked it, this hashed portion. If
Okay,
this
sir.
side is multiplied by that. Anything else? Let us solve one problem. Suppose pile lengths are say 20 meter. Okay. Pile length 20 meter and the pile diameter you take 500. Spacing you take say 3D. Okay.
So, spacing is?
Let me go to that. Let us take suppose 20 meter pile length. Okay. 20 meter pile length. Now first L1 equal to you take 10 meter. Question is say 25 kilopascal and bottom say it is continuing, say for example this is L2 equal to 10 meter but the soil profile is continuing and that C equal to C2 equal to you take say 40 kilopascal. Okay, 40 kilopascal. Diameter of the pile you take 500. So you now calculate the capacity of the pile group. Can you do it? It will not take much time. And you calculate the individual pile capacity also. for 500 mm dia, 20 meter length, having the soil profile, top layer 25 kilopascal, bottom layer 40 kilopascal. For individual pile, you calculate the capacity. From there, you will get the group efficiency N equal to QU. And then for the group, you calculate like this: CNC into AG plus PG into summation of LI into CI. First, you calculate perimeter and you do it. If any doubt is there, you tell me. First, you calculate the individual capacity that you have already done earlier. 500 mm dia pile. What will be the capacity for this stratification layer soil 25 and 40? For individual pile, you first calculate the capacity, then you calculate the block failure, and then you see which one is lower. Individual capacity can you calculate? Pi d into alpha L1 C1 LICI, alpha I LICI. In this case, cohesion is 30 and 30 I have told, or how much? 25 and 40. So both are like this. So it will be alpha equal to 1. So pi into d into LICI, alpha equal to 1. So what is the friction part is coming? Pi into 0.5 into 10 into 25 plus 10 into 40.
So why alpha is 1?
Alpha is 1 because the C value is less than 40. Up to 40, the alpha value is 1, and after that it get reduced. The chart is given in IS 2911. Have you gone through?
Yes, sir.
It is there in the chart. Intentionally, I have given value 30 and 25 and 40 so that alpha will be 1. So how much time it will take? Pi into d, d 0.5. So 1021. Priya,
Yes,
Yes,
sir.
sir.
divided by factor of safety 2. Now then you take the point bearing part. Area into C into NC. NC equal to 9. Pi d square by 4, individual pile. So pi d square by 4 into cohesion. Cohesion is there 40. Tip cohesion 40 will be there. And 9 you use. So you take that point bearing part, then you add them together. Skin friction and point bearing you add and divide it by 2.5. You will get the pile capacity. This is point bearing part, or you have divided by 2.5 and all.
Sir, on dividing by 2, it is 28.27.
Are na, point bearing and skin friction both you have added.
No, sir.
You add both of them and then divide it by 2.5. You will get the individual pile capacity multiplied by n. Multiply that by 9. How much is coming? So here you can see this is 5404 and this is 600. Which one is 600? Individual capacity was 436. So 436 into 9. It is coming 3924.
Sir, I took 436.7.
Eh? Individual pile capacity was 436.
436.7, sir.
Okay, 436.7 multiplied by 9. It is coming 3924 around, na? 39, say whatever it is, 436 I am multiplied.
3930.
Yes, and this is for the individual pile, and for the group, how much it has come?
5404, sir.
No, 5404 plus. Oh, it was the total, na?
Yes, sir, it was total.
Okay. So now you can see the block failure is giving more, by individual pile is giving less, isn't it? Whenever you are considering individual pile, the capacity is coming less, but in a block failure, the capacity is more. So the individual pile failure is governing the group efficiency here. So now you can calculate from both the block failure mechanism as well as individual pile. Am I correct? Now this is the pile group efficiency. There are different formula available basically. So this is the converse Lavera formula. This is the way also you can calculate the pile group efficiency. This is available in any book. Okay. So we have got the spacing. How to decide the spacing we have discussed. Then the failure mechanism and the group capacity, pile group efficiency. Then let us go for settlement calculation. Can you see the slide? Yes. Now you see what you did earlier. For a shallow footing, suppose this is a footing. What you did basically, you have assumed some load dispersion and you have divided the soil into layers up to twice B or so. Then for each strip at the middle, you have calculated the increase in pressure due to the foundation and the previous overburden pressure. Am I correct? You have calculated P naught dash and delta P. for each at the center of each layer. Then you have calculated you have used the consolidation formula C by Cc into log of P naught plus delta P by P naught into H. H means Hi, thickness of each layer. Then you have made the summation of it and you got the settlement. Yes or no? Have you done the settlement calculation for shallow footing this way? Huh?
Yes, sir. Yes, sir.
Now, when you have used Cc for calculation and when you have used MV for calculation, can you tell me? One formula is there, NV into delta P into H. Another one is Cc by 1 plus E naught into log of P naught plus delta P divided by P naught into H. This is one formula and this is another one formula for calculation of settlement. Where you have used which formula? Do you know? I have explained in class or not? Or in shallow footing it has been explained or not? Which formula you will use for settlement calculation? Either this one or this one. Shallow
Second
footing.
one.
Second one. Why? Why not first one? Have you read over consolidated clay and normally consolidated clay?
Yes.
Over consolidation ratio, do you know? What is over consolidation ratio? Past effective overburden pressure divided by present overburden pressure. Am I correct? So, for over consolidated clay, this formula will be used, and for normally consolidated clay, this formula will be used. And sometimes even both the formula may be used. You know the E log P curve? Huh? There you will see some curve portion and then you will got the straight line portion, isn't it? And here, do you know how to get the past effective overburden pressure? If you draw a straight line in the curve, then you have to take the bisector. You know how to get pre-consolidation pressure PC dash from E log P curve? Huh? Arey, you tell me yes or no. Have you read consolidation? Huh? You know in the E log minimum curvature, there you draw a straight line, then you extend the straight line portion, then you get the bisector, the angle, the tangent you will draw, then you draw the bisector, then you will extend the straight line portion that will touch, you will get the PC dash. Today you go to you are there only, you PC dash. You find out how to get PC dash, pre-consolidation pressure. Now, suppose your foundation is now P dash is here, P naught, that is overburden pressure is here. And after adding delta P, it has gone up to this. Then do you know that from up to this pre-consolidation pressure, this formula will be used, and from here to here, this formula will be used. So you go and read the settlement calculation for clay, and if any doubt is there, you ask me later on. What I understood, it is not clear to you. Which formula, where to use and why. Is it clear or not? Which formula to be used and why for settlement calculation for shallow footing? MV or CC? Today you read and then you ask me if any doubt is there. Okay. Next, you see for pile group what we are doing exactly. We are assuming the shallow footing here as if the load disturbance. Say for example, this is a friction pile. So we are assuming that the footing is here at 2/3 L. So from here we will be considering the load dispersion, and then this layer will go on making into layers similar to this shallow footing, and you will get the settlement. Now in case say up to L1 it is your friction footing, and there suppose a strong layer is coming. This is suppose a soft layer and this is strong layer. Then you can see we are assuming the shallow footing at a distance 2/3 of L2. This part you see. This part you see for friction pile as if it is homogeneous, we are considering the load at 2/3 L clay. Then there we are taking the dispersion, and this layer will get into layers and get the settlement. Now if this is soft layer and this is strong layer, so after L1 suppose strong layer starts, so L2 length, so 2/3 of L2, there will put the footing. And in case the whole pile is resting on weaker layer and just on firm stratum, though practically it is not a good solution, we have to insert 3D into the firm stratum. So there we are assuming as if the shallow footing is here and the load distribution start from here, load dispersion start from the bottom of the pile. Okay, so these three cases, you look into it, and accordingly you have to apply this settlement calculation formula, whatever you have read in shallow footing. So that's why I give emphasis on calculation on the shallow footing part. And this is there in IS 8009 part 2. This is the code you see. (8009) part 2. This is for your settlement calculation for group piles, group of piles, pile group. Please note this one. Code of practice for calculation of settlement for foundation, deep foundation subjected to symmetrical static vertical loading. IS 8009 part 2. So please go through this code, and the way I have told to calculate the settlement, you will be doing, you can see how they have considered it, and they are using the formula and doing the calculation part. So do you have any doubt now regarding settlement calculation? Have you done settlement calculation for shallow footing? This semester we had, isn't it? Huh?
Yes.
Yes, sir.
Then why you are keeping you are not telling anything? No response. So can you do the settlement calculation for pile group in clay? So you read the for shallow footing and then you go for the group of pile. It will be convenient because same thing. Next, have you heard the term negative skin friction? Huh? Have you heard the term negative skin friction?
No, sir.
Skin friction you have seen in the pile. You can see in the beginning of this. Okay, let me go to that. You see here, when you have calculated the load carrying capacity of a single pile, you have drawn the skin friction, isn't it? These are the skin friction, and here it was the point bearing. Now negative skin friction. So what does it mean? Negative skin friction. You see, earlier case, we had the friction in the upward direction here, isn't it? Because pile was moving down, so we have got the upward friction trying to hold the pile in position. Now there is a situation in case you are constructing a pile where the top layer of the soil is compressible like this, and it is going down, settling down with respect to the pile. If it is settling down, then what will be the direction of friction of the pile? When the pile, why this friction is acting in the upward direction? Because whenever you are giving the load, the pile is trying to go down. So to keep it in position, the soil is giving the resistance in the upward direction. Am I correct? That's why this skin friction has developed. Now, if the soil itself goes down, in that case, friction will be acting in the downward direction. The pile will be subjected to a drag in the downward direction. Since this friction is acting in the downward direction instead of working the upward, that's why it is negative skin friction. Clear? So here, this is the skin frictions we are habituated to see for pile, but in this case, the skin friction is acting in the downward direction because the soil is compressible and it is settling down with respect to the pile. So naturally, it is dragging the pile in the downward direction. That's why the skin friction is acting in the downward direction. So skin friction will increase the capacity of the pile or it will decrease the capacity of the pile? Huh? Skin friction is going to increase the capacity or decrease the capacity of the pile? Anyone, please? You see,
Increase the capacity.
this top friction part is acting in the direction of the load itself. So if you look into the capacity of it is Q, this is basically suppose a Q1 plus this friction will be downward direction, upward will be the capacity. So automatically this is what? Actual capacity minus this, means whatever load you are applying here, this is acting in this direction. So in this location, if you look into it, the capacity is coming only this minus this. So you have to calculate the negative skin friction and that has to be deducted. That will be a capacity of pile. Very simple negative skin friction calculation also, same thing, perimeter into L into C. Pile perimeter into this compressible layer thickness. Okay, let us solve a problem. Suppose this is a same problem, let us do 20 meter length, pile, 500 mm dia, the capacity will be less here. So let us take this one as 5 meter. And then it is only you calculate the negative skin friction by 5 meter and this is a 15 meter. And here suppose the question is only 10 kilopascal. Now can you calculate the negative skin friction? Huh? So it will be pi d pi into 0.5 into 5 into 10. Pi dl into c. Alpha we can use, but here it is alpha. Let us take 1. So pi dl into this. So this is the skin friction part. Negative skin friction. Clear? Any doubt is there, you tell me.
853. 7. Sir, it will depend upon the layers.
Yes. What are you telling?
Sir, means it will be dependent upon the layers.
Yes, yes. It will be depend on the layers. If it is told that the pile has been constructed in a compressible soil layer having thickness 5 meter, there you have to calculate the negative skin friction. Now you see that we have done that calculation of the pile with capacity with respect to geotechnical soil profile, and they are based on the test results we do calculate. Now there is a necessity of checking what exactly we are getting in the field. For that, in each soil report it is recommended that pile load test has to be carried out. So next part we are going for pile load test. All of you have seen the pile load test in that 1000 capacity hostel? Huh?
Yes, sir.
So there you see this picture you might have seen. This thing have you seen there? Huh? Cantilage, inside that, this type of hydraulic jack. Have you seen?
Sir.
Huh. So now let us see. So why pile load test we are doing, and it has got specific recommendation also. So for that IS 2911 part 4 2013 you have to go through. Okay. So you will download IS 2911 part 4 2911 part 4. This is, you see, this is the code. IS 2911 part 4, design and construction of piles foundation, part 4, load test on piles. Do you have this code? So what is the objective of the pile load test? To assess the actual capacity of the pile that is taking at site. while designing it. So it has got two type of test you will be doing. One is initial pile load test. You will go through this code in detail because question has come from this. So this is, you can see, initial pile load test and routine pile load test. Test type, initial pile load test and routine pile load test. And here you can see clearly written the objective of this or purpose of this initial pile load test. Determination of ultimate load carrying capacity to arrive at the safe load by application of factor of safety. Provide guidelines for setting up the limits of acceptance of routine test. To get an idea of suitability of piling system. To have a check on calculated load by dynamic or static approaches. Now you can see there is routine pile load test also. Checking the safe load determined by the static analysis, detection of any unusual performance, and workmanship. So now if you go, so two type of test you can see. One is initial pile load test, and another one is routine pile load test. So initial pile load test is carried out in a pile which is subjected to 2.5 times the allowable load which has been designed. Say one pile capacity, you have got allowable capacity 100 ton. So you will check it for 250 ton, the initial load test. And this pile will not be a part of the foundation. Clear? So initial test, this pile is not part of the foundation, and we are checking the capacity of it, and we are doing the test with 2.5 times the allowable load. Whereas for initial pile load test, the routine pile load test, routine pile test, actually this will be subjected to 1.5 times the design load, and these piles are part of the foundation. Clear? So where we are conducting routine test, where we are conducting initial pile load test, and what is their objective. So you can see the piles to be tested for routine test may preferably be selected on the basis of the following: abnormal variation in concrete consumption, sudden drop in concrete level during construction, problem encountered during boring, significant variation in depth of pile, anomalies observation during driving operation. So this way actually you can select the pile which should be tested. Okay. Now, how you will get the load from the pile load test? There is criteria. You can see 7.1.5. The safe vertical load on single pile for an initial test should be least of the following. You read 7.1.5. So piles up to and including 600 meter diameter, 2/3 of the final load, at which the total displacement attains a value of 12 millimeter, unless otherwise required in a given case on the basis of nature and type of structure. 50% of the final load, at which total displacement is equal to 10% of the pile diameter in case of uniform diameter piles, and 7.5% in case of bell diameter pile. But for 600 and above, this will be allowed to 18 millimeter or maximum 2% pile diameter. So now you can see, as I have told you, for lateral load calculation in the morning of what we have done, say 5 millimeter, now people are allowing 1%. That is related to diameter. So here also you can see the load test data that will be getting, that will be based on the diameter. So this part you have to know. What are the type of test, how the test will be conducted. Say for example 100 ton, 250 ton you will give the load, but at a time you will give no. Say 20% of the design load you are giving. Then you wait. How long will you be waiting? That is also specified. That the different settlement you are measuring, that will not undergo say half an hour, there is no change, or 1 millimeter only, like that. So this, how you will go for the load test, you can see here, it is there. This is applicable for both initial and routine test. In this method, each stage of loading shall be maintained till the rate of movement of the pile is not more than 0.2 millimeter per hour or until 2 hours have elapsed, whichever is earlier, subject to minimum of 1 hour. The maximum test load shall be maintained for 24 hours. Okay. So why you will do the pile load test? What are the different types? Initial pile load test, routine pile load test, that is for vertical, lateral, as well as compression tension, both are available. Now the next question is, whenever you do the test, there are different method actually. You can see this one you have seen. This is cantilage you are using. Whatever design load you will give, that will be the reaction here actually. So suppose a 250 ton, here you have to give more than that, say about 10% extra. So when the hydraulic jack you are pushing, it is trying to move in the upward direction, then it will get the reaction and it will push the pile in the downward direction. This is basically the way people are doing the test. This is cantilage method. Then another one interesting thing I'll show you, whether I have shown you earlier or not, I do not know. You see here in the site how this loading has been made. One truss has been made. Those are connected to the neighboring piles. So if you use the jack here, that will try to push up, then this pile will be subjected to compression and these two piles will be subjected to tension. So like this, you will get the load deflection curve, and from there you will get the allowable load, either single tangent method or say double tangent method as you do. Okay. So this 2911 part 4 you have to go in detail. From there you will get the load test data. Now nowadays some other tests also available, dynamic. Now you can see some important test I can show you. This is pile integrity test. What is the length of the pile that you can check with this? This is called pile integrity test. In bottom you can see this is called Zoom test or cross hole test. What we did basically, while inserting the pile cage, two pipes are inserted and here one transducer is there to receive the vibration, another transducer is there to emit the vibration. So it will go simultaneously. For the whole pile health, you can see whether any honeycomb is there or it is properly densed or not. So to check the health, nowadays these type of tests are coming, that is pile integrity test or cross hole test. These are very all important projects, mostly 100% they are doing this pile integrity test now. And but this does not give you any load. This test does not give any load, but this give you idea regarding the quality. But conducting these two tests, these are the pile load test. This is cantilage method. But nowadays again another one method is available, that is called dynamic pile load test. Dynamic pile load test is there. Dynamic pile load test. In case you cannot go for this cantilage method, you can go for dynamic pile load test. Okay. So what we have learned today? Is it okay? Any doubt is there? You tell me. Any doubt is there?
Sir, can you please explain that part again?
Which part?
The load capacity increases or decreases in the case of skin friction.
Okay. Coming. This one. You look, suppose one pile is there. Just a minute. Suppose this is a pile. Okay. Now Suppose negative skin friction is not there. What you will do? This is the skin friction. And has your point bearing. It is clear. Q equal to what? This skin friction part plus this point bearing part, isn't it?
Yes, sir.
Yes or no?
Yes.
Now, so in this case, what is happening? The pile is moving down and the swell is giving the resistance. Let us now come to the negative skin friction part. In negative skin friction, what is happening? Now the in negative skin friction, the swell is moving down. When the swell is moving down, what it is doing? It is dragging the pile in the downward direction. Okay. And the skin friction in the pile is acting in the downward direction. Now you compare both the figures, this figure and the earlier figure. In this case, what is happening? You can see very simple from the free body diagram. This friction plus point bearing minus this friction plus this friction minus this one plus this one is the capacity, yes or no? Huh?
Yes, sir.
But in earlier one, this one plus this one equal to this one. So which one is taking less load?
Second one, sir.
So this one is taking less load. By how much? By this much.
Skin friction.
Negative skin friction part, isn't it?
Yes.
And calculation of negative skin friction is very easy. ID into this L part into C. Very easy. Clear?
Yes, sir.
Okay, anything else? So what we have covered today, you see, first we started with the lateral load carrying capacity of pile. As per IS 2911, you have already calculated the lateral load, how to get moment, how to multiply it with the modification factor, everything you have done of your own today. Then we have gone to pile group. Column. Each pile divided length, everything is decided by the load carrying capacity. We have seen what is the spacing. While going for spacing, there is possibility of interference of the pressure valve. And if you cannot put it too far apart, because if you get it too much apart, then the pile cap size will be more. It will be very difficult to accommodate them within the space, and it will be costly. Looking all that into account, we have decided and another one thing I have told you, the vibration during construction. That also affects the strength of the lean concrete. So after looking into it, you will be deciding the spacing of the pipe. That is 3D, 2.5D, and 3D, 2.5D, and minimum we are providing say 3D for friction pile, and for end bearing we are going for say 2.5. Okay. Now After
All
spacing,
our.
we have gone for the file group capacity
मेड इजी
calculation.
का जियोटेक के बुक के नीचे,
In that case,
मेड इजी का जो
for
बुक खुला हुआ है उसके
individual
नीचे,
pile we know, and for
हाँ,
pile in group
पीछे से.
for clay failure, and from there we have calculated the capacity, and we can get which one will be the actual capacity, the minimum of these two, that is individual pile multiplied by n, or say as a block failure. After doing that, pile group efficiency we have read, and then we go for the settlement calculation of pile group. For that, I have told you to read the settlement calculation for shallow footing, and you should know where to apply CC, where to apply MV, and how in pile group, depending on soil profile, whether it is homogeneous soft layer or strong layer, or depending on that, where the shallow footing will rest, that is there. Accordingly, you calculate the settlement part, and IS 8009 part 2 will follow. Next, we have gone for the pile load test, which is very much important to assess the load carrying capacity of a pile. Cantilage method you have seen, then you can go for dynamic method. And if you look into the pile load test difference, the initial pile load test and routine pile load test, and their merits, demerits, their objectives, and how to get the capacity from the pile load test, that also guideline is there. So, and for that you have to know IS 8009 part 4 you have to read. Okay, so this is all about pile. Well, we have not touched. Next semester we'll read well, and we'll go for the also structural design of pile, pile cap, and everything, and how the load will be calculated for each pile in a pile group from the column loading, that also we'll discuss. So any doubt is there, you tell me.
Sir, in case of the group pile group,
Hmm.
we have calculated means one in group and one for single. So
Hmm.
can this happen that individual is higher than the group one?
In this case, we got individual is higher, na?
Sir, but that individual was that was
No,
we
we'll
are
take the
coming from
minimum.
group.
We will take from the minimum, whether block failure or individual failure, which one will be minimum, that will take.
And sir,
Okay.
at site we will be means providing that pile cap, that one only.
Which one? Pile cap.
Yes, sir. Means a group pile will be only provided.
There are some situations so we go for single pile, but in that case, if we don't give restraint on either direction, then it will be considered a three-headed pile, and it will not be able to take in lateral load. It will take very less lateral load. Generally, we go in group, always preferable. And generally, we go for more 3 and more than 3. Any doubt is there, you tell me. So it's better now, we could finish and there is no class today. But you take preparation for the exam. You inform for the first A section also. Whatever we have explained to you today, everything will be part of the exam. And whatever we have read earlier, everything you have to read. Otherwise, you will not be, there is not much option in the question paper. Earlier, what we have covered, retaining wall, isn't it? Earth pressure, sheet pile, embedment depth of sheet pile. Everything you remember, or you have forgotten? Okay, then we can stop here. Wish you all the best for exam. Huh? Shall we stop?
Yes, sir.
Yes, sir.
Yes, sir.
But any doubt is there, you can ask me anytime. Okay, we are always in the department, not restricted by heat wave.
Sir, please tell about the IS code that we allowed from your part.
Huh?
Allowed in exam from your part.
From? You write in the chat box.
Sir, which IS code will be allowed from your?
For my part, there will be no IS code will be allowed. I put the question in such a way that no IS code is required. But Dipankara ma'am, I think, will give some reference IS code he will allow. She will allow. I do not allow any IS code in exam. So for my part, you can answer without IS code.
Okay.
Okay. So take care of your health. Preparation is okay. Have you started taking preparation? But Rebecca is coming again. So restrict yourself a little bit from this cold, this heat wave. And Rebecca also, that is also heat wave, na? Okay, then wish you all the best for exam and take care of your health.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Yes.
Okay.
Thank
Thank you.
Thank you.
Sir.